Honor to be in Connor's class with my friend Joe and with all of you. Today we're going to share our experiences, our journey, learning from a number of computer vision projects that we did over the past couple of months. And before cracking on, we will first do like a little self intro. And first is my friend Joe.
Yeah, so my name is Joe. I'm a first year here at Harvard. I'm studying computer science and physics. And I met Xiaolong from my intro to computer science class, the CS50. And then so we met early on in section, and then I saw something on his screen that was interesting. We talked about computer science for quite a long time, coding projects and things like that. And then so this is our final project that we worked on together that we're trying to present.
That's right. And my name is Xiaolong. I was originally born and from China. Growing up, I moved around a little bit. Kind of did my high school in the UK and then college in Japan, Tokyo, and then now doing my studies at Harvard, working on applied statistics for political science. And more specifically, I was interested in causal inference. I did a number of projects related to what Connor has been doing. And last semester, because I didn't take any computer science class formally before, so I thought I would take a computer science class. And then luckily, I was able to run into Joe. We realized that we both use this knowledge organization software that's called Obsidian. That's also why Joe reached out in one of the sections at first. And then we just decided to talk a little more about projects. And eventually, we did this project together. And we're really excited to share with you the whole journey that we went on.
Let's jump in both for those introductions and thank you again for coming.
Yes. So the first thing we'd like to show is a demo of everything we've built, just to have you see what we put up.
So what we built was a goat tracking system for farm that Xiaolong's family owns. And then so you have these goats passing down there. I guess we'll talk more about it later, but in the demo, at least you guys can get an idea of what it's doing. It's just counting goats for the farmers. And the bottom left corner there, you can see we're using a computer vision model to make sure you're finding the center point of each goat. And whenever they pass this gate, we count it as one goat. But yeah, on the right, there's a dashboard for all of this. And top is just a little simulation of some goats with some physics logics, but all of it together is the final project that we have. But the most important and significant part is just counting the goats, how it's significant and what we learned from it.
That's right. It is of Joe's genius that we made this void simulation where the idea is in real goat setting, when the number of goats correspond to the actual goats in the farm, you can actually draw the boundaries or fences where you can trap the goats and see how they react in certain behavior. Because the goats, they follow something that's called herd behavior. They follow one another. And then oftentimes you want to optimize the route of how where goats are going in a farm. And this, we thought like this is kind of a proof of concept that we wanted to provide to the farmers, but it's not something we built. The main work is here in the vision work. But it's fun.
Can you talk a little bit can you
Yeah.
talk a little bit about the motivation for goats in the first place? Was there a need on the farm that wasn't being addressed? Was it expensive
Right.
to do? Tell us more.
Yeah, we will jump into that topic if that's okay, because we have prepared a lot of slides for it. Before we get started on the actual thing, we want to give out a couple of caveats. So one, we're not professional, serious computer science experts at this point. So everything we do is just similar as what you would do when you see a project and then try to apply machine learning algorithms. We make mistakes, and then one of the goals is to share our mistakes with you. Second, we worked on a real problem and it didn't really work although you saw the technology working, but applying that technology to reality is a different story. And that's one of the main things we want to elaborate on today. Thirdly, despite all the seemingly failures or mistakes, we still think everything is worth sharing. So the whole point of this talk is to motivate a thought that taking action on real world problem is really the key. And everything that we will discuss henceforth will be in service of the message. Yes. So where can you find problems? I guess we read blogs, we talk to people, and then we take classes to learn where to work on problems, how to know the problems you work on are worthwhile. From our own limited experiences so far, we think academic journals, they may be able to provide cool solutions in theory, but in fact, it often doesn't work. So our intuition is not from academic journals to find important problems to work on. It's always good to talk to people who are close to you, who know a lot about the context, the problems that they face in their work and life. And in this particular case, the problem kind of arose from my own family who knows the challenges of running a cashmere farm, which we will talk a little more. But basically, the line of thought that we wanted to provide here is you talk to people who you're close with, try to understand the context of their problem, and that will give you way more edge in understanding and identifying key solutions to tackling those problems. So this is the whole project started as a final project idea for the CS class that Joe and I took together. Before stumbling on this idea, we talked about a number of other things. For example, creating social networking applications where we can connect all our friends or remind us to say happy birthday to our friends when it's their birthday, because we forget. And over time, we realized we wanted to work on important problems. And I was reminded that China, and specifically my hometown, Inner Mongolia, has a lot of gold farmers. And these gold farmers, they face a lot of difficulties in their career. Inner Mongolia is famous for two things. One is rare earth metals, and another is these cashmere golds, which I briefly alluded to. And today's story is about how those people, the cashmere farmers, face challenges in their life and how we saw those challenges and wanted to propose our own share of solution to those challenges. Some general macro statistics just to give you a sense of importance of the problem. Inner Mongolia alone at the moment supplies roughly 30% of the world's cashmere. Over 3 million cashmere golds exist in the region. Some are wild and some are raised by farmers. And the share that we wanted to help with is the humanly raised goats, which are really facing a lot of breeding problem, contagion problem, which are quite severe. And because, as you see, Inner Mongolia alone supplies 30% of the cashmere, it is a very well capitalized industry, right? And the very bottom of the supply chain, you have the goats and the goat owners, which are goat herders. And then one step up the supply chain, you would have people who scavenge and collect the goat farms or the goat furs, and then to put them into refineries and then turn them into raw yarns, which are what people use to make cashmere garments. Almost every single step of the supply chain is very well capitalized, meaning that international and domestic businesses invest a huge amount of money building factories, trying to run the industry as efficiently as possible. But this is not the case at the very bottom end of the supply chain, which is the gold raising business. One of the main problems with the gold raising business is that almost all of the man-raised, farm-raised goats are raised in a very segregated manner, and I will talk a little bit about what that means in the next slide. Yeah, so this is what I meant. Region has created a number of large businesses, but the problem that we want to address is not tackled over the years. By segmentation, we meant that usually if you go to Inner Mongolia and then you ask, what's the biggest farm? And normally the biggest farm will be some state-owned farm that owns a little over 10,000 goats, which is really a small number if you go to any other country and ask about how many cattle a big farm raise, how many pigs and chickens that a farm has, right? It's a very fragmented area. And these families, the goat herders who run these farms, they work tirelessly and laboriously every single day, try to make sure that the goats are safe. And what that means is everybody in the family, usually it's a couple, senior couple, wake up 6 a.m. in the morning and then they will go into the field. They actually live in the field in something that's called a Mongolian yard, which is like a movable tent that they can change locations from spring to winter, depending on where the goats will be grazing on. And then they will be out in the field for the entire day, try to follow their goats as the goats graze on the grass, and then make sure that water, sufficient supply is provided for all the animals. And they take no breaks every single day, or weeks, or years. And that's just their life, right? It's a very hard life, if you can imagine. On top of that, they don't make a lot of money. Before we started, Joe is asking about the business model of all these farmers. The hard truth is they don't really have a business model. They just own these goats as commodities. And then every single year, they don't have a stable stream of income. For example, they don't really sell services to any companies. They are unwilling to sell these goats to the market because once you sell 10 of your 200 goals, you'll be losing that's 5% of your net asset overnight. And that's really destabilizing for the entire family. And usually these seniors are still providing for their go to college, or even after people get married, they will still support their family, younger families, with these goals. So it's really of high stake to these people, and they don't make a lot of money. And the worst problem with, I guess, the worst thing of being a goat farmer is every single year you will have to make sure that breeding goes well, and that is really of the highest importance to a farm. And breeding often goes wrong because these newborns, they're really fragile, and sometimes you go to sleep at 3 a.m. in the midnight, and then you think the newborns will be okay, but once you wake up an hour after, the baby's dead because of freezing or cold air. So it's really dramatic, as dramatic as it sounds. Is really a dire problem that we wanted to help with. So everything we've said, we wanted to give you some context to motivate why we wanted to work on this problem. In the field, we were able to find a farm that we could talk to because it's connected to my family who's running this farm. And then we called a bunch of people, doing interviews, asking what are the bottleneck difficulties that they face running a farm like that. And we have found that one of the main pain points is really to replace the labor on the ground. And a large proportion of the labor on the ground is to enumerate the right number of goats when the goats are leaving the pen, right? And also when they're coming back to the pen after spending a whole day grazing on the land. Yeah, so as I've said, because the business model is so broken that people don't make money and that you have to be on the ground the whole time. The thought is, if we can really replace labor with computer vision technology to count the goals for them, then they don't have to hire people, or they themselves can be freed from this labor to do something else, and that will save them a lot of money. Yeah, and the way that they're doing it is just by eyeballing the goals every single day. And we've tried to eyeball the goals using the security footages, and it's really hard. With all 20 years of experiences, you just can't count accurately.
So then, Xiaolong, I remember discussing this with Xiaolong when we were brainstorming ideas for the project. And then we are doing our productivity ideas, this idea, that idea, note taking ideas. And then suddenly he mentions this. I was like, oh, this is an interesting idea. It's like a real world problem that we can solve. It will impact people, all the people that spend time to count these goats. And so he mentions this. Coming from my more like computer science background, I was like, oh, you can just insert vision model, count the goats. Should be fine. I've done a little bit of analysis with human tracking before for sports analysis. So I was like, okay, we just apply this model for goats and it should be okay. See what we have. Oh, so I thought it was okay. And then so we looked for models out there that I can integrate here. The first one I looked at, oh man, it's okay.
I'll do
Yeah.
that.
The first one I looked at was SAM. It's from Facebook. Segment anything model. So you run this and you can segment out things because we're not looking at humans anymore. We're looking at goats. And then the idea is just look at where it says goats and then you can count the entire farm. Problem we went into first, it was very slow. So it's good because it takes a lot of computational power. And then with this comes time. And then it's not something that you can actually deploy in a real farm. So that was gone. The other thing is actually it's not too accurate too. Because the other big wall is that these models are not trained on this specific type of goat. So these are special to Inner Mongolia. And then a lot of these computer vision models, the reason why they were good for these humans was because they have these special facilities that photograph humans in different angles, doing different actions, sports, cooking, all of that. That's why they're so good at recognize humans. But they don't have much data on these Cashmere goats because there's just not a lot of them on this world. So when we tried to run these models, it just couldn't count. It couldn't recognize, as you would see in the initial video footage that we had here. So yeah, what did we try to do to solve this? Well, we tried to think back more systematically about how these people count. So the workers, one of the methods that they do is they mix in different colored goats within them. So for every 50 white goats, you'd have one black goat, and then you would just count how many black goats there are, and then multiply by 50. Yeah, but of course that's a big way to like lose error. You could have plus or minus 50. Let's say you lose one black goat there. You just lost 50 goats, and each of them kind of brings in a decent amount of assets to the farm. So you just lose a couple $1,000s just from missing a goat over there. So we would not want to do that. Another way is counting just specifically just the horns because that's more identifiable than a blob of white. Or sometimes they paint a certain distinct color on the horns, like a little blue mark on the horn, and you just look at blue in your computer vision model. But of course, all of these have their own sorts of errors too, because you can have blue that's not on the goat. You can have another thing that's shaped like a horn as well, and you get that confused. I think the other image that we had over there was just showing how different all the goat types were. Yeah, so these are just some of the different breeds of goats that you have. And then so you can see a computer vision model being extremely confused about the color, exact shape. So it would be difficult to employ such a general model onto our specific case. That's the main.
Yeah, and just for everybody's interest, this is how Inner Mongolia Cashmere goat looks like. They're very fluffy, which makes it even harder to track for these vision models.
So at the end, what we tried to do is we went back to a vision model. This one's called YOLO. You only look once. That's their memo. So what this one does is that you can send in and feed in some of your own data to do what's called fine tuning this model. So we manually annotated many frames of what our specific goat looks like, and YOLO learns this. So this is kind of what it will look like. You just stream in videos, draw these bounding boxes. This is exactly what the goat looks like. Okay, now the model will know, okay, this thing I've never seen before, that's a goat now. And then so from that, you can train the model and see how well it does. But the other important thing for all this AI model stuff and just machine learning in general is that it needs a benchmark to know how good it's doing. So it's like, it needs a direction to know when it's tuning little things inside the model, it needs to know if it's going in the right direction or not. If you don't have this, it'd be asking you to go somewhere without giving you any directions. You don't even know if you're headed warm or cold. So we needed to have a ground truth. That means understanding exactly how many goats there were actually in the video. So we manually counted, it was like half an hour of video, counted many times and saw different results. How did we come up with different results every time? We just counted and counted until finally we settled down, okay, this is probably a number, 100 something. And then that was a model, a metric that we used to evaluate the model. So you tune different parameters in the model, feed in different data, and then we see it converges closely, more and more close to the actual ground truth. And yeah, that's the way we tried to settle down this problem.
And here, one little detail that's worth discussing a little more is really how humans count in this case. How Joe and I counted could be seen as how people model different problems differently. So for example, here you can see this is how, I don't know why this is switching. This is how Joe counted at the time when we were both looking at the same security camera footage of goats going from below the line and all the way up to the top of the screen. His way of encoding information is basically once in a while you will see a goat reversing its direction, going from top to bottom instead of bottom to top, and then that's when he will strike a horizontal line. So this way you can really see like how often the goats will reverse its direction, which will be useful. And this is not how I kind of jotted down the notes. I couldn't find my notes, but my notes were mainly in numbers. I would write 1, 2, 3, 4, 5, and 1, 1, 1, 1, 1. And the reason being, once you open the gates of these farms, the goats will just swarm in, right? They won't go in nicely queued like humans, right? Sometimes 2 or 3 goats will squeeze in the narrow door all at once, and that would be specifically difficult for the model to pick up because it doesn't track whether it's 2 or 3 goats sometimes. So by writing down 1, 2, 3, and then 1, 1, 1, 2, 2, 3, you would know like how frequently goals will come in as groups instead of individuals. And at the end of the day, when we try to come up with a ground truth and later a model that can track and identify the goals correctly, we can triage those ways of counting goals differently and then use them in our favor to build a more comprehensive model. So a bit of awareness in how you understand and approach even the evaluation of the models could in turn help you refine the model even more.
Yeah. Okay, so then we had that issue solved. We could get the model to a decent amount of accuracy. I remember Xiaolong, after a bit of this, he called back to the farm again. He was like, okay, we've achieved this level of accuracy. How accurate do you really want it to be? Of course, the answer was 100%. Like, they don't want to miss a single goat because missing a single, let's say you had 500 goats when you went out. And at the end of the day, it comes back and your model says, oh, there's 499. Oh, you lost a goat. You would go send to go look. And then they won't want this sort of confusion at all. So the goal was 100%. Of course, we never actually achieved this, but still we wanted to see how far we could go with this project. And then so we thought about a deployment of our prototype of a model. And then that's when we ran into our second wall. Physical hardware, when you try to deploy it, has much more issues than just simulating it in your own environment. You have our models on our own laptops and it could work okay. But now you want to work it offline, separately, in another place that you're not present in with the same level of accuracy. And it's harder to do. In different places, you could stream if it was good internet. So for example, if the farm was located in an area that had service, you could stream the video to your local computer and do the model there. But of course, it's in Inner Mongolia, and this type of wiring would be more difficult. Similarly, hardware, if you were to do it specifically in the goat farm over there, you would need some raw computational power. Let's say theoretically you could bring a laptop there too, but then you'd face other issues like what if it's raining? Now you gotta put a code around it or something to secure it. And then there's latency too. Your battery could also go out. Where are you gonna generate electricity for that? And it's all of these things replacing your laptop, or all of these problems just start to show up when you think about deploying it. So that's when we hit our second wall about trying to deploy.
And you wouldn't believe how bad the stability of these models are. Like you would imagine after all the crazy hand labeling of all the goats, the model would just perform beautifully at 100% recognition rate. But in truth, whenever there's a rain or there's like sandstorm, or even when the pole that was holding the security camera that's shaking a little bit, the recognition rate will drop dramatically, because the hand annotation data set it's overfitting the model to recognize goals in a well-conditioned situation. Whereas in real life, these conditions change, weather, shakiness, and that would just in turn destabilize the performance of the model.
So many issues. Yeah, or like something gets in the way of the camera. Like that could happen too, or there's water on it. Now you need a system to like clear it. So many different things to worry about once you're thinking about deployment.
So yeah, after sharing our lessons and journey, is pretty clear and apparent that we didn't transform the industry, but we did learn a number of things worth passing on to you guys. And lesson,
Yeah. The first lesson that we learned is working on a real problem that others will be benefited by if you provide a solution. That was one of the greatest motivations for this entire project. And the starting point too is when he mentioned this idea. Is like, oh, we can be really impactful in this, employing technology in a place that doesn't have as much of it. So you put it, and it's a real problem, and you could really save some people some time.
Yeah. And slightly different from doing simulation work and applied stuff in classroom, where you're not bounded by real life constraints. When you're working on a lot of real life problems, you'll realize, oh, this thing doesn't work. We don't have a lot of time to work on this. If you order a new security camera, it's not going to ship before X amount of deadline. So all of those will come up all at once. And then it is of your duty to figure out how to optimize for better decisions.
The second lesson is try to keep things simple. So there's a lot of times, especially I think people who are into engineering fields or things like that, they're over optimizing in the beginning for parts that they don't even use at the end. So for us, it'd be like thinking about all the different models that we could use. Would it be SAM? Would it be YOLO? Would it be this or that? And then only to find out at the end, you can't even deploy like 80% of these in the actual field. So yeah, always try to make things the simplest. Don't overcomplicate things, because a lot of times it's just discarded.
Yeah, and we had a lot of time calling the people working in the farms, right? Like talking to people who are actually experienced in the field will help a lot as well.
The third lesson is
yeah.
generally the technology that is applicable, and if you want to apply those types of technology to your specific problem, it's not often tailored enough. So you have to do some work to tailor it for that. So for us, it was the goats, of course. Vision models are not trained on these goats, but there exist technologies where you can apply your own data set to make it specific to your niche. So whatever your problem is, most likely some solutions out there will need a little bit more fine tuning and tweaking to fit your specific need. It won't come so easy, but it's important to be willing to put in these work.
And yeah, so this connects more to what we thought about the whole project after we knew we couldn't deploy the whole tech stack timely. We realized if we were to help automate and systematize the whole goat farming industry, then it would not only require just us deploying, the vision models. It would also mean we need to help redesign how these factories are run using hardware and software, and how to educate local people to actually use these technologies. So it's a much more complicated problem than just developing and using one piece of technology, but also how to build a system architecture that combines people, software, hardware together to make the industry more effective. Yeah, and through the process, you will learn a lot of things, and then you will collaborate with people, and then you will identify real problems, which are all fun.
Last lesson, last lesson is working with people that you genuinely enjoy working with. Because a lot of times there'll be problems that you run into in your project. If you're doing it with somebody that you don't really like working with, it's very easy to be just discouraged from these things. Whereas if you enjoy working with each other and you enjoy each other's company, it's sort of, I guess, encouraging to go through. It's easier to go through these problems, and you'll feel more rewarded at the end of it.
Yeah. And Joe is incredibly talented in, talking to interesting people, starting different projects, working on different interesting ideas. And if you have, questions for Joe, he can definitely share a bit more on his later ventures into different domains. So yeah, that's probably all that we wanted to share today.